Okay, we will start. Meanwhile, we wait for the rest. So the event of today will be divided in two sections. The first section will be a short introduction by each member. Then we will have the questions on different topic discussion. And at the end, the idea is to talk about the challenges that Chelsea is having on. It's also interesting to see if any of the participant has any good comment about any of the designs or the things that another is doing. So first, myself is Federico. I'm part of LambdaClass. I will be moderating this event. Ali, do you want to go next? Uh, Ali, can you introduce yourself, please?
Me. Sorry, I had the connectivity problems. Hi, so my name is Eli Ben Sasson. I'm a co-founder and president at StarkWare. Should I say a bit about how I arrived in the L2 space?
Yeah, sure. You have 1 minute, 2 minutes to that.
Okay, so I was doing research in cryptography and the mathematical, the mathematical underpinnings of computer science. And then in around 2013, I swallowed the red pill. I attended, it was 10 years ago, almost to the day, that I attended a conference, the Bitcoin San Jose conference, swallowed the red pill. I was probably the first to realize that general purpose proofs of validity with zero knowledge, without Starks, Snarks, things like that can be really useful in blockchains. So I was one of the co-founders of Zcash, later on of StarkWare, and right now, proud supporter of Starknet L2.
Thank you, Ali. Jordi, can you go next?
Yes. Hello, I'm Jordi Bailina. I'm the technical lead at Polygon zkEVM. I've been in the space since 2015, and I'm an Ethereum developer, and mainly I'm an engineer.
Great. Nicolas?
Yes, sure. So I'm Nicolas Liochon, and I work on Linea, ConsenSys, zk. Started actually as an R&D project in 2019 for us as a solution for scalability for Ethereum 2. Back then, a lot of work was around sharding. And we started to work on rollups for anonymous payments, then partial anonymous payments. And we started to work on zkEVM in 2021. And interestingly, at the beginning, we thought that the zkEVM was impossible to do. And we discovered that it was actually possible. So here we are.
Great. Bobbin, can you go next, please?
Yeah, sure. Hi, I'm Bobbin. I'm a project lead at Polygon Maiden. This is one of the other rollups within Polygon, which is like zkEVM is doing something different where we don't have EVM compatibility and pursuing a slightly different use case. And the way I am fairly recent, I would say. I've been in the space in 2018, 2019. I am an engineer by training and kind of like got into zero knowledge proofs. I was fascinated by the concept, and then kind of like zero knowledge virtual machines, and then kind of that led me to kind of working in the L2 space.
Excellent. I'm not the host of the event, and we're waiting for a few of the guys that need to join. If anybody from perfect, Alex, thanks. You could join. So,
Hey.
who's next? Tuggle, could you introduce yourself, and then Alex would go next.
Hello, my name is Togrul Maharamov. I do research at Scroll. We are a zkEVM and rollup on a zk rollup on Ethereum. I came in the space in 2017. My background is in computer science and distributed systems, so I've been working for a few years on consensus protocols and stuff like that, but I've been always following Ethereum in the background and helping to the work on sharding, etc. And then at some point I realized that actually the best way to scale Ethereum is through rollups, and I got rollup pilled and became a rollup maxi. So yeah, and now I'm here.
Excellent. Thank you, Tuggle. Alex, can you go next? Could you introduce yourself, please?
Sure. Welcome, happy to be here. Thank you guys for organizing. I am co-founder of Meta Labs, the company behind zkSync, or ERA zk rollup. It's a rollup focused on the mission of bringing freedom through blockchain to everyone in the world. So, like, our mission is to accelerate the mass adoption of blockchains for personal sovereignty, and this is why we started with zero-knowledge proofs in the first place, or zk rollups. That's the only way, from everything I know, how we can scale blockchains to get anyone in the world access to them in a fully permissionless way with full trustlessness, where you can only rely on math and open source code and not on trusting some other people. This is why I'm so excited about it.
Thank you, everybody, for doing the introduction. We're having some technical difficulties with some of the people that need to join. We will start nevertheless. Meanwhile, StarkWare people help me get 3 of the other invitees. So the first question I would like to ask, it's about EVM compatibility. Like, there are a few teams here. Oh, great. Excellent.
There we go.
Just in time. So, Patrick, could you please introduce yourself, and then we go with Calvin?
Yeah. Hi, my name is Patrick McCrory. I recently joined the Arbitrum Foundation doing research. Sorry that it's so dark here. It's like 1 a.m. for me at the moment. And historically speaking, I'm a researcher, so I did my PhD in cryptocurrencies from 2013 to 2016, and generally just did a lot of L2 research since then. So yeah, very excited to be here.
Excellent. Calvin?
Yeah, hello. Can people hear me? I don't know. My mic was being weird. Yeah, good. All right, good. Hi, Kelvin. Yeah, I've been working on Optimism, I guess since before it was Optimism. And now I don't even know what I do anymore. I kind of just run around and break things. But you know, roll-ups are my life at this point, and I have nothing else going for me. So what are you gonna do?
Excellent. So as I was saying, we will start with a few questions. The first question that I have for everybody, and please let's try to have everybody talking. I might interrupt somebody if you are talking too much, or if we want to give some time to somebody else. But the first question we have is about EVM compatibility. Some of you guys are focusing like being fully compatible with the EVM or somewhat compatible with the EVM. On other teams are having a different take on that. So is there anybody that wants to start like explaining their point of view? I don't know. We can start with you, Jordi.
Yes, we are zkVM compatible. We try to be as equivalent as possible to the Ethereum. We are code compatible. The idea is that any user can use the zkVM without any tooling, any special things. They just connect the MetaMask. They can go to Remix or to any wallet that they are already using and just use it as normal as they would use Ethereum. That's the idea of the Polygon zkVM.
Anybody wants to, like, Ali, what's your take on that? Like, Cario is not EVM compatible. Like, why did you try to go that route?
Yeah, so I think it's probably me against everyone else, but that's fine. Yeah, we have a different virtual machine called Cairo. And I would actually, I want the listeners to ask the following question, like, why? Like, you know, okay, it's not that we were not aware of other existing architectures, and it's not like we weren't aware that one way to get scale is to take some existing machine and generate proofs for its executions. So, you know, in my academic life, I both built a machine. It was called the TinyRAM. It was the first general purpose machine for which proofs were generated, and of course also compiled from C and other things. So why did StarkWare do this thing, right? And I think what I'll say is we faced similar questions when we came out and talked about scaling through Starks. There were a lot of other technologies that people thought are better suited, Groth 16, Snarks, things like that. We knew them, I was a co-founder of Zcash. I'm well aware of the many benefits of Snarks and their short proofs. So why? Now, actually, I prefer not to answer the question. It's all about bringing the thing that is best suited to the task at hand. But I think that all the listeners who are curious should go and check out what is Cairo, what does it feel like programming in it, and I think you'll see the answer. Why is it that we didn't go with an EVM? But I'd rather just leave it as a mystery so that people explore it further.
So I can jump in as well if you want. Oh, sorry, go ahead.
No, I was going to say that Maiden is actually also not EVM compatible, and so Ellie, you're not alone.
I agree. Sorry,
but I would say I maybe will give some answers, not all the answers, I guess. But in my mind, there are some reasons for why you want to kind of do one versus the other first. There are a few reasons for which I don't think really we thought initially, but which I don't know if hold anymore. One is, for example, efficiency. To go with a different my first instinct of why I build a different VM was let's make it as low cost as possible. And now with zkVM, actually, Jordi has done is fairly low cost. You don't need to worry about costs. I would say simplicity may be better. If you can have something that is more easy to kind of prove that it worked correctly, the more complex the VM, the more complexity there is. And maybe one of the reasons to build a different architecture is the simplicity of it. But in my mind, even the simplicity part can be overcome. And what is more important is catering to different use cases. So if you, let's say, zkEVM is very well, or EVM in general is well established, and you don't really, you get the benefits that Jordi described, you don't really need to learn anything new if you're an EVM equivalent, you basically just deploy your smart contracts and they work. But EVM doesn't cater to some use cases, privacy is difficult to do on EVM, or if you want to kind of do stateless type of state where you don't store everything on chain, it would be difficult to do with EVM. So in my mind, it's not against EVM, it's complementary. You want to have different use cases covered. I don't know any industry where or maybe there are very few industries where a single product dominates. You usually have different products catering to different use cases, and I think that's it's important to build EVM compatible and also non-EVM compatible products that different people may want to use for different purposes.
Great, Alex. You guys did something in the middle, right? In some way, you have an EVM compatible ZK virtual machine, but at the same time, I understand you also are proving the LLVM or something like that. Could you explain it, please?
Sure, and I would say we're not in the middle. We're taking the best of both worlds, and let me explain that. The approach StarkWare initially started with is to build a virtual machine that is optimized for being provable in internal knowledge proofs to get them absolute maximum efficiency. Now, if you go with a special compiler for optimized for this virtual machine, then you're going to get the maximum efficiency of the code transition. I think it still matters. I think it still matters even after all the great improvements in the prover technology and bringing the cost of transactions really to a fraction of a cent, because you will always you can always add more, and there will be always demand for more. And we're speaking about bringing billions of people and millions of transactions per second onto this new emerging internet of value. It will matter. If you're bringing all the games and all the value transactions and all the payments of this world and all the trading, NASDAQ alone does some insane numbers of transactions, and you optimize for latency, you optimize for all these things. Performance in the long run will matter a lot. In the short term, compatibility matters. So you want to take the existing ecosystem and port it without hassle. So this is why we focused on the compiler approach, where you can take the code that is written for EVM, you can compile it, you can port it, everything works essentially out of the box. There are some exceptions. Some tooling is not yet supported. It will come. We're in very early stages, but it will be there in a matter of weeks, months, 90%, 99% there. And after that, you will also be able to add other programming languages to compile into this optimal virtual machine. But you will have an option to really get the absolute maximum performance while still having this compatibility and working in the in the familiar environment.
Great. If you guys want to like interrupt somebody else, please let me know. If you want to pause or have a more like discussion based pod, let me know also. So now it's Togrul from Scroll that will give his point of view.
I think Patrick wanted to say something before
Oh,
me.
sorry,
But
Patrick. You go. Sorry.
Oh yeah, I can jump in. Yeah, there's two things I want to say. So I guess from the Arbitrum perspective, the idea is the EVM plus for the EVM's the baseline, but then there'll be a new upgrade called Stylus that will allow you to use other languages like Rust, etc. So EVM's baseline, then hopefully we can add on other languages after that. But I don't really want to be talking about this Arbitrum. I think what's more important is to set some context here about why are rollups exciting and the whole idea of virtual machines. So if you go back to the original sidechain paper in 2015, what was really exciting about that proposal was that we could deploy experimental blockchains, take our Bitcoin, lock it into that experimental blockchain, transact as much as you want there, and then bring the coins back to Bitcoin. Now, obviously, that never worked out on Bitcoin. Bitcoin couldn't really go after that dream, but rollups did. And what's really cool there is that you can have these experimental blockchains, but still derive the security of Ethereum. So I'll take, Kara was Starknet, Optimism had the OVM, Arbitrum had the Arbitrum virtual machine, and now WASM. I forget what zkSync is. I think it's like LLVM or something. Maybe you can talk to that, Alex. I forget the thing. Polygon Hermes has their very funky zkVM. I don't think it has a real name. You can name it if you want. The Polygon Maiden is some UTXO model. And Scroll's doing they're doing like the old Optimism approach. We can probably talk about that later. I think Calvin has some thoughts on that. But out of all of that, what's really cool is that it's EVM compatible. Project has literally built their own virtual machine that's very experimental and very different, but inherits Ethereum security. And that's really what makes the rollup roadmap really exciting. So I just wanted to highlight that really cool point about why it's all this important.
Yeah, go, Togrul. I don't need to like introduce everyone. Sorry, I want to do it a little bit faster.
Yeah, sorry. So we can probably list quite a few things that are wrong with EVM. So like 256-bit word sizes, etc., that in hindsight don't really make much sense. But the reason why I feel like a lot of people, when they claim that, oh yeah, EVM is not performant enough, etc., they assume that the current performance of EVM is the limit of what it can do, but there are a lot of tricks and optimizations that you can do to speed up EVM, even ignoring the prover side and like the rollup side. And on top of that, EVM had 8 years, almost 9 years at this point behind it. So there's a lot of documentation. So my example is always, if you heard about smart contracts for the first time and you Google how to implement a smart contract on a blockchain, the first 100 search results or 1,000 search results are going to be about Solidity. So it's much better documented. It's much more accessible to people who are entering the space just because of the vast amount of examples and the vast amount of tutorials out there, etc. So it's a no-brainer for us to build on top of EVM. And while I think that there are other approaches and there are viable approaches and they make sense, it'll take years for them to catch up in terms of the same level of resources that are publicly available for us.
I can add something to this as well. Is an important thing that you get when you're using the EVM is that you're using a standard that is defined, not by yourself, but by someone else. It adds value. And as well, it helps on decentralization because it means that you can have multiple implementations of the same standard from different actors, but you can switch from one to another if one actor does not deliver enough. So it's something that adds a lot of value. And the side effect that you get with the zk EVM is the possibility for a single rollup to have actually multiple provers validating this rollup. That's a multi-prover approach proposed by Vitalik a few months ago. And it requires all the zk EVM to apply exactly the same state transformation. It has some technical constraints, but it adds at the end as well the value that you get something that is equivalent to what you have on the layer 1 client, which is multiple implementation of the same standards. And when you want to validate your rollup, you can actually rely on multiple provers, so you don't have a single dependency. A single bug will not create a false state. So it adds a lot of value. And considering the complexity of this technology, the fact that you can have multiple implementation using different arithmetization, different prover technology has a real benefit, in my opinion, for the end users.
I think there's also a natural decentralizing force to using the EVM, in the sense that if you the second you use something that's not the EVM, now you need language design people, you need compiler people, right? You need documentation people, you need all these people to construct the context that Toggle was talking about. And that context doesn't already exist, so you construct it. And so the fastest way to construct that context is to usually keep it within a single org, so that all these people, the compiler people talk to the docs people, talk to the language design people, and all these people have to talk to one another. And so what tends to happen is that you get these very, very large organizations, just naturally. It makes sense. Of course you want a large. It's much better than trying to do this decentralized work. And so you get, the second you move outside of the EVM, you get this centralizing force that ultimately makes it much more difficult to decentralize an ecosystem. So if you want to decentralize development, the reality is you piggyback off of something that's already done. It's not, I mean, of course there's trade-offs there, but practically speaking, the easiest way to decentralize is to piggyback off of something that already exists, right?
If I could say something, I just want to say that one of the unintended consequences of starting down, a new journey with Cairo and Starknet is that because it's a new model and a lot of tooling and infrastructure needs to be built, then it attracts a very special kind of developer, ones who are drawn to the beauty and power of the technology being developed. And I think the biggest asset right now of Starknet is this very impressive early adopter, really gigabrain set of developers. And our moderator Fed is, of course, one of those, but there are many, many others. So there's something to be said for a new world being built.
Yeah, and just a comment on that, because I'm aware of 2 projects for Starknet as well. One is Warp, that's going to be a transpiler. But I spoke to a team recently called Kakarot, who are building like a EVM on top of Cairo that's going to be available there. So I'm really excited to see that as well. So maybe you're going to be EVM compatible eventually because someone else built it, which is really nice.
Yes, Kakarot is an amazing, and Warp, they're 2 amazing projects that actually promise to bring Ethereum, either Solidity or Yule or the virtual machine, onto Starknet. Which is also very exciting.
Here, I would like to put an example of what means being EVM compatible. When we started the project, we decided not to have account abstraction because we wanted to be the same that Ethereum. Ethereum does not have account abstraction, so we just did being as equivalent as possible. But with all the effort that the community is doing with the AP 4337, we have a transaction for free. You just need to deploy the smart contract on top of the zkVM, and we have a account abstraction. This is the example of being on top of Ethereum, and being on top of Ethereum means this being equivalent, opcode equivalent. You just take the smart contract. You don't need to recompile. You don't need transpilers. You don't need special things. You just take the same smart contract, you deploy, and it works exactly the same. That's the goal. And this is, and this is when you are doing this, is when you are start getting all the traction, all the useful. You are getting all these synergies that the community, the Ethereum community is bringing. So for me, this is amazing.
Yeah, maybe
this is true. Like I like to,
Alex.
I would like to add a counter point to this, that going back to what Patrick said, like if we wait for layer 1 to innovate and then embrace it, then it has a lot of advantages because we're going to follow all the same standard, and it's going to be compatible between different things, and all the services will work just the same way. But we will lose this opportunity to innovate and actually show the way, which can be then backported to Ethereum. So I think we have this opportunity and we should be embracing it. So at zkSync, we did that with native account abstraction, which largely followed the designs of EAP 4337, which were being discussed as we were implementing it. And I know that StarkWare did it even earlier. They originally started with all accounts being natively abstracted. And that gives you some very interesting superpowers, which you don't have with EAP 4337. For example, any account can pay for its fees in any liquid token. If you only have USDC, you can pay in USDC. You don't have to pay in ETH, and you have to think about gas. And it's a lot easier to onboard new users without having to explain to them all these complicated concepts. You just tell them, here are your virtual dollars, and you can use them to pay fees. Right? Just Alex, as one example.
But EIP 4337 gives you that.
Oh, you can do that with externally owned accounts.
You can do that.
Yeah. I mean, 4337 still has loads of problems with it. It's a very awkward standard. I much prefer a new opcode for that.
Well, we can take it offline. But like if you have a legacy account that is externally owned, you can't really there is no way to do it.
Yeah, it's called the message.sender problem, pretty much. If your contract uses message.sender and you want to use that standard, it will not be supported for EOAs, and it's really, really frustrating. I remember that because that was my old startup. Hated it.
Or if you want to do a multi-call and you want to go around the problem of ERC20 approvals, you guys followed recently there was the
with the account abstraction. If you want to do that, of course, you need to create your account abstraction. But with account abstraction, you can perfectly do that.
Yeah, but like then you have to switch to this new wallet that supports account abstraction instead of using your legacy wallet, which exists.
Yeah, you will do it. You do exactly the same that Ethereum.
Yeah.
Just to add something, a counterpoint. So I agree with Jordi that I feel like, and also just to add, being Ethereum equivalent doesn't mean that you can't add anything on top of what already is there. You can be equivalent and then extend the feature set that is already there in Ethereum. So what Arbitrum is trying to do with EVM Plus, they're equivalent, but they're adding features that don't exist in Ethereum. And so there's nothing constraining us or Polygon from adding features that we want to add on top of the existing features. It's just we want to be compatible with all the existing features. And then if we feel like there's something unnecessary that we want to add, we are free to add it. It doesn't really affect the features that are already there.
Cool. I would like to move to another topic. And I will be more like a devil's advocate to break the ice. I would like Patrick on Calvin to answer first. Why do you think it still makes sense to continue doing an optimistic rollup when ZK is working?
Because it doesn't work well enough yet. I mean, it's fine. It's fine. Everyone's gonna move to ZK eventually, right? Everyone's you're architecting your systems well enough so that eventually you can all these systems today have been completely designed to separate the proof and the execution, right? If you're an optimistic rollup and you're still doing this thing where you're tying the proof and the execution, you don't know what you're doing, whatever, it doesn't matter. No one's doing it that way, so it's fine. I can say that. No one's doing it that way. So you separate proof and execution, and so then you're setting yourself up to eventually move to the ZK world. I still think that the optimistic world is just way easier right now. It's simpler. It's easier to build, it's easier to maintain. I think eventually the ZK stuff will get to that point, and then if you've designed your system well enough, you just slot it in, right? This is sort of the ideal future state. The properties that these ZK systems give you long term, great, fantastic. I think that they're still annoying to maintain. They're annoying to build. It's hard to decentralize these things. I think there's a benefit in the short term to an optimistic system, but like there's also other cases where an optimistic system is just useful, like in very specific edge cases going forward. But you know, give it a couple years, and I mean, all these systems will be zk anyway. It's just about the path that you take to get there, right? And our assumption is that this is the cleaner, sort of easier pathway that gets you to that end result.
Yeah, I mean, I can just echo that in a sense. So one is it's just easier to build new features on top of an optimistic rollup because they've been around for 2 to 3 years longer in production. Like Stylus, for example, is very easy now to add in because a lot of the hard work and the fraud proofs is done already. The other one, like a lot of people like to say, optimistic rollups are cheaper than zk rollups in terms of just the proving costs and stuff. I think there's some really cool practical examples around that maybe I spoke to Jordy once about in person. So my understanding of Hermes is that they're using CPUs over GPUs because CPUs are just cheaper. So it's not really a speed problem at this point. It's just cost. You want to make sure you reduce the cost of the prover so it doesn't impact the users. And I know George's going to say it's really cheap as well, so that shouldn't really impact it. But the whole point is, CPUs are still cheaper than GPUs, and that's going to impact proving speed in the long term. So one is this cost, and two, I think the real one is this extendability. It's just way easier to extend. Then my third point, actually, and this is sort of from a conversation from Calvin a few weeks ago, it's not really good to look at these rollups just in terms of, like, all a zk proof or a fraud proof gives you is integrity. But that's really just from the perspective of the bridge and that bridge holding funds. And that's not the best way to define the rollup either. You could have multiple bridges for the same rollup that all rely on different, ways to protect the funds. They're just bridge operators. Most of the time it only makes sense to have one bridge, but you could obviously change your bridge and have a different proof system, but still have the same rollup. And I think that's a really cool philosophical point that most people miss out on. Maybe Kelvin will add to that now.
Yeah, like piggybacking off of that, I think that everyone made this mistake when they first built a rollup, and I can guarantee you that every single person in this call made the same mistake because everyone made the mistake, which is you sit there and you think like, I need a proof system. So if I don't have a proof system, then I don't really have a rollup, right? So then everyone starts building these proof systems, and then they build their chains within the constraints of their proof systems. Everyone does this, and some people tweaked it more, some people tweaked it less, and the end result is that like your chains are very much defined by your proof systems. And I think that the lucky thing that the optimistic rollup people had was that it was easier, and so it was easier to realize that you should build the chains first and the proof systems second. And this is something that I think that in the zk world will happen, but the end result is that the node software is much easier to maintain. The software in general is much easier to maintain.
And I would like to react to, yeah, sure. So two points. One is about the complexity. Let's be clear. I mean, a proof system is complex. I mean, there's a lot of mathematical stuff, and there are a lot of innovations. So not only it's complex, but it's a complexity that is changing. That's clear. However, from a system design point of view, you have a very you can, when an actor does something, when a node participates, it has to prove that it behaves correctly. In distributed systems, what is complicated is Byzantine behaviors, people doing things that they should not be doing, and it's something that you can nearly remove when you're using zk rollups. There's the proof is valid, yes, no, there's nothing else. So that makes things quite simple from a system design point of view, and even if you have a complexity somewhere, this complexity does not leak to the protocol that much. So it simplifies a lot of things, and that's how actually we can have this fast exit of rollups because it's very binary. That's something. As well, when you design a rollup, you have multiple layers, and you've got a lot of modularity. So even if there is a complexity, you can actually separate the concerns, saying there's one part which is the client, one part is going to be the trace generation, one is going to be the prover scheme, and one is going to be the implementation of the mathematical layers. And you have all this, and these components can live independently. Like for us, for example, the mathematical library that we're using is GNARC, and it's something that has been existing for a while, that you can use independently, and I know it's the same thing for other rollups as well. The client, you can reuse one. That's what we do, and many do this. You just have to extend it to that feature. So there is a complexity, but it's really something that you can manage from a software point of view, which means you end up with this complexity on the zero knowledge part. And it's something that is going to be stabilized. I mean, today there are a lot of innovations. That's why actually rollups, zkVM are quite fast because of all those innovations. And at a point, what we will get is something that is fast enough, and that's it. It will be done. It won't change every 6 months, and we will be there.
I mean, practically in the zk rollups today, the complexity does leak all over the place, right? If the complexity didn't leak, then you could just run geth and prove geth directly, or you could run something else and prove it directly. But practically, the complexity leaks all over the place in the zk rollups, and it's just a function of maturity.
It's not the complexity thing. I mean, the complexity to just prove geth is basically Ketchak, which is quite expensive, absolutely, for a prover. But two things could happen. First, I'm not even sure, even if your Ketchak is important for a type 1 rollup, us, we're targeting a type 2 with a different set function. However, two things could happen. It's possible that actually we will find a way to have a fast Ketchak. And in this case, you can take your client as it is. And it's something that could happen in the next 2 years. That's not something impossible at all, not from us specifically, but from anyone. And as well, there's a work in progress on the client itself, the Ethereum Foundation, to change the state representation. So once we will be there, we will have a state representation that will be optimized for zk rollups, and then you will have with the same client for a zk rollup and for a standard layer 1 client. And one of them is going to happen. Either we'll solve Ketchak, either the state representation in the layer 1 will change. So I think the way I see it is today we are type 2 because that's the simple choice in a way. But I think everybody will become a type 1 within a few years, solving your point about the clients.
I'll play a bit of a devil's advocate here. I feel like if you want a generalized layer rollup to deploy any execution environment, an arbitrary execution environment, that at the moment optimistic rollups make sense. So I heard that somebody is even building a Game Boy on top of Optimism just because it's easy. You just compile anything into it and it works. But at the same time, the disadvantages of having optimistic rollups are also quite clear. You have slow finality, slow withdrawal times. If you want to build light clients, they are quite difficult to work with optimistic rollups, etc. So I feel like while we are it's a bit more painful for us right now because the tech is not quite there to have to build seamless zk rollups seamlessly, but we're getting there, and in a year or two I feel like optimistic rollups are also gonna switch to zk rollups, and the future is zk rollup based.
I should just highlight quickly that there is no such thing as zk and optimistic rollups.
Calvin, can we let Bobin speak on that?
Yeah, sorry.
Yeah, I think there was a point earlier about like you kind of build a chain first and proving system later. And I actually would like to disagree with that point. And the reason why I would like to disagree with it is that I think if you know the capability of the proving system, it actually allows you to do things that maybe you would not be able to do under other proving systems. So like to give a concrete example, zk gives you a lot of like different like superpowers that you can apply, which if you didn't use zk, you probably would not be able to do. And as an example, like in Maiden, for example, what we're trying to do is allow people to prove transactions locally. And basically nobody else except for you locally has to execute a transaction. And if you don't have zk, there is no way you can do something like that, because unless you can execute things locally and generate a proof that you can send and somebody can verify it, this is not possible in a different paradigm. So if you first build a kind of like a chain for something more kind of generalized without thinking about what capabilities does a given proven system give me, you would probably not think of this as a capability that you can enable. But if you're thinking, okay, I have zk and I can enable different features that are, previously even in the blockchain space in general were not possible, then you have quite a lot of flexibility and can think about like very, very new design approaches.
Yeah, I mean, just to jump in there, I mean, both zk proofs and fraud proofs just fall under the same umbrella of verifiable computing. So you could do that with fraud proofs, just as obviously it just has the time delay and it's slower, but you could do stuff like that.
I mean, maybe,
Well,
but I'm not sure how practical it would be.
Maybe to clarify my statement is that the correct way to build an EVM equivalent chain is to build the chain first and then build the proof system. But I think you're correct. You can build interesting things that are not quite EVM equivalent if you do it that way.
And maybe one good example of this would be data availability and differences in data availability approaches, where in zk rollups we have a choice between publishing the call data, transaction inputs, and the state deltas or transaction outputs. In optimistic rollup world, you only can publish the call inputs, and this leads to a bunch of different trade-offs. So like with state diffs, some transactions will reuse the storage data that is being published, and they will essentially become many times cheaper, like potentially hundreds or even 1,000 times cheaper than the same transactions on optimistic rollups or on rollups that use call data.
Yeah, can I just re-explain that part just for the people listening? So like, I guess what Alex is alluding to is that, an optimistic, well, it isn't a rollup design either. You got to make the data available so someone else can compute a copy of the database. Either you post the entire transaction, which is the call data, which is what most optimistic rollups do, or you post the state diff, which is how you update the database. So let's say it's like a price oracle. They're always updating the same storage slot. So if they do it thousands of times, you just post that one update, that one storage update, just so people hear. Because that's very technical, so I think it's good to explain that once or twice.
Yeah, actually, Starknet on zkSync, you guys are using state diff, right? Could you explain why you decided to do that early first, and then Alex on the rest can comment on that?
Well, because it's more efficient just to update the state diff, and you can, because basically the validity proof makes sure that you operated with integrity. So I think that's why you do it.
I would say that it's different for different types of transactions. There can be transaction types that are cheaper with call data. For example, if you have a lot of, you need to read a lot of storage data and do some computations, and then you only do like one simple output. That would be cheaper on optimistic rollups or on systems like Polygon zkVM. So this is actually a trade-off, right? So like you can, like, if I saw some DEX that was built on Arbitrum that specifically uses that feature, and it has a lot of, like, the contracts are constructed in a way that will make trades on optimistic rollups, for example, cheaper than on zk rollups using this approach. But the reason we chose this is because it gives you this super linear improvement. So like it's with rollups using this call data optimistic rollup model, you can do data compression, which can give you like 50-80% of your costs on data. But this thing can give you like 10x, 100x, 1000x on certain transaction types, and specifically on Oracle updates. So it will be possible to have much more frequent Oracle updates, like Oracle updates every second if you want, on zkSync and Starknet, which you can't, like, it will be prohibitively expensive on optimistic rollups or on systems like Polygon zkVM. This is why
I just want to add a few things and say, like, so this is not just theoretically possible. I mean, the StarkX systems, which are really one could argue the first dedicated app chain that uses validity proofs in production. These systems have been humming for more than 2 years. we've regularly posted proofs that cover hundreds of thousands of mints of NFTs with immense updates to systems. Even on a roll-up mode for DYDX, we have amortized gas that is less than 500 per transaction, because many of the transactions touch the same space storage. So using validity proofs, even in roll-up mode, is very efficient, not to mention all of the Oracle ticks that don't appear. And people who are curious, how can this be? I just want to say the code is all written in Cairo, in this new and strange, dedicated new machine that we invented and created, and it's all accessible for everyone to use. So I think if you're curious about this, you should really check it out and ask yourself, how's this thing working, seamlessly for several years and doing these things. It is quite magical, but it's also extremely accessible to developers who want to be early adopters. So, the magic is here, and it's all for you to use.
Yeah, let me give me my point here. I think this is for me, this is state diffs against just publishing transactions. It's a super interesting technical debate. It's clear that here, for the people understanding, is if there is a small set of people that's trading and you want to do like a lot of transactions, I'm sending you something, you send me back, you send me your send back, then state diffs makes a lot of sense, because it's you just update the results and you don't have to update all the million transactions that you are going back and forth. Okay, but when the proofs are getting, so when you are first in normal, so this happens in some applications, but not in all applications. And the important thing here is that when you are generating proofs very fast, so if you are reducing the time between proofs, this compression that you're getting is getting worse, because it's not the same compacting all the transactions traded in one day that all the transactions traded in maybe 30 seconds. So you don't have that much. So this winning by aggregating the diffs, when you are doing a lot of proofs, you are not getting that bad. In the other side, when you have the transaction, you have the origin of the transactions. The transactions are more, in general, generated by humans. So this is something that in general is much more compressible. It's to put an example, machines, they work ones and zeros. You get a program, for example, generated for a machine. It's much harder to compress than when you are compressing a text, because a text is created by humans. So this idea of a transaction example, for example, when you are sending something, you are sending 1 ether. You are not sending 1.4.567. You have a very small precision disk. You can compress that much better. If you want to do the state diff, when you're subtracting from the COM, for example, you need to subtract the gas, and the gas is a calculus that generated with when you're executing those transactions. So here, I believe that in normal, so that in regular transactions, in normal transactions, the compression rate can be much better. But again, I think it's interesting, because we will see in the future how these things happen. And again, if you want to, if you have some real application that maybe is doing this and trading, you have always the option to run a kind of a type 3. You can just run a smart program, specific smart program that's doing something and update the state once in a while. So at the end, I don't see, we need to see. I believe that's much better to publish the transactions. Publishing the transactions, the financial system works by logging the transactions, not by logging the state diffs. State diffs is like is the transactions. So, but here again is and the blockchains are about transactions. But again, this is an interesting debate. I really am very interested to see who is going to go better here in the future.
Just to add to what Jordi said, so we're also going to use transaction data. We're going to publish transaction data. So there are a couple of things to consider. One, I feel like in a lot of cases, the argument that state divs have a much smaller footprint is quite overstated. And while there are some specific use cases that will allow the footprint to be much smaller, for an average transaction, the difference is not that drastic. And yeah, of course, you can make an argument the user behavior and the developer patterns can adjust based on what is the cheapest way to do things. But currently, it's not, at least based on Ethereum, there's not that much of a difference. And secondly, there's a situation that if you post the state diff, you essentially have to trust that the state diff was computed correctly. If, let's say, there's a bug in the proof system that causes the state diff to diverge from the actual state diff of the state machine, then you are essentially reconstructing a wrong state, and it actually happened already once in real life, and you end up with an incorrect state that you reconstructed based on the fact that you trusted that the proof system will prove that the correct state has been submitted.
Look, there is one thing, for example, when you're publishing transactions on chain, those transactions are final. So if you put the transaction, you know that transaction is going to execute. You're going to prove it or not. If you are putting a state diffs, until the proof is not there, that data don't means anything. Okay, so here the cool thing, for example, in the Polygon zkVM is that the transactions are put it on chain faster, and then the proof can go later on and can be aggregated on that. But the transaction once on chain is final in a decentralized manner. You don't need to trust the sequencer. I mean, if it's final, it's final. It's in there. So this is, I think, this is another advantage on putting transactions on chain. But again, this is not a black or white debate, I think. Yeah,
I agree. It's a trade-off space, but like I just wanted to add a counterpoint, Jordi, to what you said previously, that cold data are usually more human readable and easily compressible. A huge part of the cold data is the signature. The signature is not compressible at all. And for zk systems that publish state diffs, we completely omit the signatures. And or like whatever like large complex inputs that can be there, for example, other zero knowledge proofs, verifying zero knowledge proofs recursively, like for private applications, for private transactions, confidential things, is going to be a lot cheaper on systems with state deltas. But the other arguments hold. So it's a trade space. It's going to be like different benefits for different use cases.
Just here for me, just something that we are working very much on, that is you can substitute all the signatures of a block by a proof. Of course, you have to compute the proof, but you can substitute all the transactions by a proof that you hold those transactions, and this doesn't change. So anybody can change the proof. This proof goes in the data availability, so you don't pay. You don't need to pay the verification of that proof, but the state is final. So you have all the state that there, and you compress because it's just can be a small proof, and this can compress. So you can remove mainly the signatures in there. So yeah, it's a state diff. So if you put transactions, you can also remove the signatures from the data availability.
That would be an interesting hybrid to see how this works.
Yeah, we're working on that. You will see.
Nicholas, do you want to jump in? I saw that you unmuted yourself. Oh, okay. I can make my comment. So I basically have like two comments. The first one is I've always sort of argued that the ideal rollup will have both, and that's because if you want to have a forced transaction, so you want to make sure a user can forcefully include their transaction and force it to be executed, which is really important if you want to protect the customer. Obviously, you have to post the transaction data, and that's just a necessity. Then the state diff is good for various special situations like trading, as everyone's highlighted here. I think the second point to highlight, and it's really to do with the state diff. So what makes rollups really exciting is that there's a full audit log of all the transactions that have been processed. But by using the state diff, we actually lose the transaction data because all we post on chain is how we update the database. And I ran into this about 2 or 3 years ago with Starknet, actually, because I wrote this SOK on layer 2s where I was really trying to understand how the rollups worked and try to systematically compare them. But it was really difficult to compare StarkAx because I couldn't get the transactions. I could only get the final update. And so I couldn't actually work out, myself, what was the, per gas cost of a transaction. And that's just one of the practical problems that will pop up with that approach. We may lose some of the transaction data. But Ali, go ahead, just jump in.
Well, I mean, it's a double-edged sword, right? It's also for the StarkX customers who want this, they actually want this privacy, and of course you can have the best of both worlds. So it's called Volition. It's going to be a feature of Starknet in one of the upcoming releases, and then applications or users can decide what they want, right? If they want data to be on chain, they can do that. If they want it to be off chain, they can do that. And of course individual applications can decide to post the raw data as transmission onto the layer 1. There's nothing forbidding them but for the gas costs of those. I think, right, the best thing is to put it all in the hands of the users and give them the tools to choose whatever they want, and the application developers. I'm willing to bet, we'll give these tools to developers. I'm willing to bet that 99, like when Volition is turned on, I'm willing to bet that like 99% of the data will remain off-chain, even though it can be done on-chain. And I think even though you already have the option of reporting to the layer 1 each and every, let's say, price tick oracle or whatever you want, you can do this. I'm willing to bet that like 99.99999% of applications will choose not to do that when they have the choice. But of course they have it already.
Any other comment on this? If not, I would like to discuss a little bit as the two last topic. What's your take on the proving system? Which solution you're using and why? And then to close this round of questions or topic discussion, the idea is to discuss a little bit about the decentralization of the sequencer on the prover. So who wants to go first on the first topic, the proving system? Like, I think Linnea, Nicolas, it's interesting that you talk. It's one of the few projects I'm not very familiar with, so please go first.
Yes, sure. So what we first have is arithmetization. It's not really a part of a prover, but it's important to mention it. The arithmetization publishes traces of the execution in a non-cryptographic way. Like, for example, the numbers that you have are not on a finite field. They are basically 256 integers, and that's it. So those traces are then going to the prover, and the prover has multiple steps. And what we do, we're using an approach with a Plonkish approach with an IOP plugged to a polynomial commitment scheme that is using lattices for hashes. And the idea of using lattices for hashes is basically the polynomial commitment becomes incredibly cheap. That's the main point. So you have this mechanism. Then you need to add, like all these type of schemes, a recursion to it in order to lower the size of the proof. You reach a given level, and at this point you want to go to the layer 1, and you do a final proof with Plonk on BN254, so you can send this to the layer 1. That's how it works. And two things on our end. One is, I think it's very important to decorrelate the arithmetization from the prover. That's really important, that you can have this decomposition and that you don't have this cryptographic stuff leaking all over the place in the way you transform the execution to something that you can prove. That's something that is quite key. Second, performances of a prover are very important for many different reasons. Some of them obvious, like, okay, I mean, if you want to do more transactions, you need to be faster, and you want the cost to be lower, but it has as well some side effects when you want to test, for example, with Ethereum EVM test suites. You have 15,000 tests to run. If your prover is fast, it helps a lot to run this test. So something as stupid as engineering is already useful. And that's it for a high-level description.
Somebody
I
wants
can
to
go
go next. Ellie.
Yeah, I can go next. So, okay, I want to say something. I mean, the title of this is Peace on L2, and I don't want to stir up unnecessary, quarrels. But I do feel obligated to listeners to point out that, not all systems have their core security turned on as intended. And it's an important thing to be aware of. It's actually extremely important to point out, because users entrusting their funds with systems that rely on certain security properties should know exactly what is turned on and what is only claimed to be turned on. And please do your own research on what is actually working and what is only a promise to be fulfilled at some point in the future, and what is said to be working but with all kinds of caveats. So I'll leave it at that. I'll say, I was a co-inventor of several proof systems out there, and I am a very strong believer in just the pure Starks that have the safest and the most future-proof technology. Post-quantum secure require in the interactive version only some collision-resistant hash, or if you want to make the non-interactive, you require only the random oracle model. All of our systems in production and in alpha have never been turned down without the proofs, for every and each state transition. And I think when you look at the numbers, you see that the combination of Starks with a very efficient Turing-complete machine and very ergonomic language that is Cairo gives you just amazing performance. So we have the lowest amortized gas cost in production over any of the systems, period. And this only gets better as you scale more. So I know that many of the validity rollups use Starks or components that we co-invented various things. I think that the most efficient way is just to go purely with Starks. So that's what we use.
I guess I can go next. So we also use Starks for Maiden. I think there is one twist that I would add, is that the Starks that we use for Maiden is like Starks over a very small field, which, well, it's not very small, it's 64 bits, which helps a lot with efficiency. I think Starks in a small field, in my mind, and obviously because we're using, maybe I'm biased, but it's by far the fastest system that I've ever seen as compared to any other proving system. I will probably disagree with that a little bit about like keeping a pure Stark, especially if Ethereum is your target. Like, yes, I think pure Starks are, quantum resistant or, safe against quantum computers. But if Ethereum itself is not yet there, it doesn't necessarily like bias much at this point yet. So if because once Ethereum gets to post-quantum security, then yes, I would say pure Starks will probably also make sense. But right now, for like practical purposes, it may still make sense to like wrap a Stark proof in a proof that is cheaper to verify with Ethereum without sacrificing much of the security in that way.
Alex or Jordi, do you want to add anything else? Or Toggle?
Well, I can continue here just to mention, for example, for arithmetization, we're using PIL. So PIL is a language for writing arithmetization. This allows us to abstract a lot of the arithmetization from the proving system. This has been very useful for auditing because it's very clear it's very clear to Auri the limitation. On top of that, we are using, as Bobby mentioned, we are also using Starks with this Goldilocks prime field. Here to mention that we are using a lot of recursion. This is really amazing. With a single proof on chain, we can prove as many batch as you want. So we aggregate infinitely, and that means that the proving cost in terms of gas cost is a constant, is a fixed cost in the network. So it's, if you are doing 1 transaction per hour, this is just what you pay, no matter how many blocks are you processing there. And the final cost is it's the cheapest cost. Is so we are using Flonk to wrap this Stark in the last thing, and this is 330K cheaper than Growth 16. So this is, we're using Flonk. We are paying a little bit more in the construction of the prover, but the result is that the gas that we are paying for the proof is about 300K gas per proof.
Alex, do you have any comment?
I can also add shortly to it. I agree with everything that guy said. I agree with Eli that Starks are, and with Bobin that Starks are the most efficient proof system as of right now. I also agree with Bobin that it's not yet meaningful to have post-quantum. So like what Jordi is doing in Polygon zkVM with wrapping the last step in a proof system, like in Plonk essentially, to make the proofs fully succinct makes a lot of sense. You don't lose a lot of efficiency, but you gain a lot of cost benefit on chain. And I think this is what, like, until Ethereum gets to post-quantum, this is what everyone is going to be using.
Rule, do you have any comment? You guys are using KeySG, right? Plonk plus KeySG?
Yeah, we're using Halo 2 with KCG. So just to add, I'm probably the least qualified here to talk about proof systems, but yeah, we use Halo 2 with KCG, and the way we do it, we have basically the outer layer, the inner layer, which proves either so we have a combination of circuits that prove either individual opcodes or like a set of opcodes, and then we combine them together into one big proof, which is then verified on chain.
Great. Only one comment from my side. I think it's pretty interesting to see the differences between more like academia and the industry. Like many of you guys are using Starks, and yeah, like me personally, I like them a lot. But yeah, that's interesting to see that there's so many agreement on that front. Cool. On the decentralization of the prover on the sequencer, like, what's your take? I'm not very aware of. Yeah, Ali, go ahead. You're muted, Ali.
Sorry, I just want to drive this point. Like 5 years ago, I think it was, we came up with Starks. A lot of people said, oh, but the individual proof size is too long. You know, it's not the way. You have these better things, Groth 16, and there were many, many other things. And of course, there's a lot of brilliant science going on. We said it then, Starks are the way. I think there's more acceptance of this now for scalability. The same team that said this 5 years ago is saying dedicated virtual machines that are, modern, ergonomic, are the thing that you should focus on. And we believe in Cairo. We think just like Starks are adopted as something that everyone's going to use. I'm very confident that Cairo and variants of it, and I think Maiden, I'll put it there as well, is something that is dedicated to optimize the proving time. They will be the things that will be adopted. So we'll talk again in 5 years about that. But I think, and again, the listeners, check out Cairo 1.0, see for yourself. Sorry I interrupted, Fede.
No, perfect. Regarding the sequencer, like there's many people criticizing, especially those that are not part of the Ethereum ecosystems, that criticize that in most cases or almost every case, the sequencer is centralized. What's your opinion on that? Like how what's your answer?
I can go first. The criticism is valid. We have not succeeded. We have not fulfilled the mission of scaling Ethereum if we introduced centralized trust assumptions for liveness and for censorship resistance. So we like to do this, we have to decentralize sequencers. Period. Now the question was like, would it be better not to launch anything, even with decentralized security and decentralized censorship resistance properties from layer 1, and just wait for this perfect solution to like materialize and then launch? My opinion, no. Like by starting now with giving some trade-offs and centralizing sequencers initially, but then decentralizing them completely was the right move, because we learned a lot. We can keep the system guarded for this training wheel phase, to keep the fund secure, to avoid add additional layers of protections for the users. Once the underlying proof system is completely tested and mature, we should definitely decentralize the sequencer, and we at zkSync are working on this already.
Yeah, Jordi, go ahead.
Yeah, I can say so. For me, I think this is the decentralized sequencer. This is something that's common to all of us, including optimistic rollups. We share these problems, and as Alex says, this is something that we need to solve. Here, I would like to explain like 2 ways to approach this. Okay. One way is we propose proof efficiency. So here the proof efficiency, the idea is that you can have, so imagine that anybody can be a sequencer, okay? And then the transactions get sequenced when the transactions goes on chain, okay? This is decentralized. You can decentralize that really fast. We can decentralize that today, okay? The problem that has this is that the finality time is going to be the finality of layer 1. You will never be better. If you're a layer 2, you are not going to be better than the layer 1, unless you create another consensus system that temporarily takes in front, that goes in front. Okay, and this is the other solution. Okay, but then selecting what's the consensus mechanism in order to decentralize the sequencer. This is you are going to be in the trilemma here. Okay, so you're going to be what you want to sacrifice, and you will have to make a different sacrifice. And this is the where it's going to be the debate. In Polygon, we have a lot of experience in consensus systems there, but here the way for me to decentralize the sequencer is building this consensus, or going to a faster layer 1 and then just not building, just using the consensus of Ethereum.
I can say something about. Sorry.
Ali, can you wait for Toggle to speak, then Patrick, then
Sorry.
No,
yes.
No worries. I feel like a lot of people are missing the point that decentralized sequencer in rollups doesn't increase the safety properties of the rollup. It's solving a UX issue. So if you have a decentralized sequencer, the probability of censorship is much lower, because you temporary censorship, because you can still go through the layer 1 enforced inclusion, but that'll be super slow and for a lot of use cases. So for example, if you're censoring Oracle updates, 12 hours censorship is essentially equivalent to infinite censorship. So what we're trying to solve with decentralized sequencers is not what people are trying to solve with L1 decentralization. It's a completely different problem. And that's why I push back when a lot of people say that, oh yeah, if you add a consensus to an L2, it just becomes another L1, because it doesn't. You still retain the same correctness properties of the underlying layer, with the small assumption taken into account depending on the proof system that you use. But you're just improving the UX of without relying on the underlying layer. So the more decentralized your layer is, the less likely it is that you get temporarily censored.
Patrick?
Yeah, I can just make a short comment. So when you say decentralizing the sequencer at all, I think it's important to highlight there's two different roles, and Togrel sort of got to that. So the sequencer's job is to take users' transactions and then pass them on to the executors. The executors pick up these transactions, they execute them, then their job is to convince the bridge that this is the transaction and this is how it should be executed. That's the entire point. That could be a prover or it could be a state defender, whatever. They're just convincing a smart contract about the execution of a transaction. And there are two different problems to decentralize. As Togrel mentioned, the sequencer decentralization is really about a UX problem. We want to make sure that there's a sequencer available so they can always process your transaction. And depending on how you decentralize that, it can impact your user experience. If you're trying to constrain MEV by sending data blobs that eventually get decrypted, then you slow down the confirmation time for the user. So there's lots of UX problems around that. So I feel like today the main problem is actually decentralizing the provers or the state defenders to guarantee safety and liveness of the actual system. And then later on, it should be the sequencer. And just from Arbitrum's perspective, because I guess I should highlight that, these are actually decisions now for the DAO. So our job is to really provide them with proposals, or at least how we think it should be done. Then hopefully they'll vote on that or decide themselves. And I've had a short discussion with the DAO already about that. It was actually quite interesting to see their opinions. They're very proactive.
Ellie.
So the decentralization. At the end of the day, all of blockchain technology is really about providing a neutral, inclusive infrastructure that enables individuals to implement any social function that they want. And social functions are things that may have immense personal, emotional, financial value. And this value is based or is pegged to the social consensus. So at the end of the day, all of these technologies are technologies for society, for society to use. Now, the only way they do things better or different than the current system is about how you deal with the agency problem and how you make sure that things are inclusive on every level, so that you don't have one person shutting things down or now incentivized to reap bigger benefits. That's the biggest challenge, and that's the only thing that blockchains are here to do, to have this inclusive layer which solves the agency problem and the integrity problem for social functions in a better way. Now, why is that important? We with Starknet realize that no matter how amazing the technology will be, if it's not clear to everyone, to people in failing countries, to people in oppressed countries, to just people in average countries, if it's not clear to them that this is the reality, that this is a system that is truly inclusive on every level, development, operation, the day-to-day operation of things, then this will fail. And to the extent I think that projects today will succeed or fail, it is ultimately only about this one question. Will they manage to truly be and also convince the world that this is a technology to be trusted in its decentralization? So what I want to say is, and I think I'm speaking probably for all of us, people are asking, will you decentralize? Will you really open source stuff, as you've said? Will you really make it accessible? I want to say it's in the incentive of the ecosystem that is building this. If they understand what blockchain is about, there really is no other way. Because you understand that no matter how good the technology is, if it's not really and truly inclusive and fully distributed on all levels, you understand that this will fail. You can push it for a while and try to fool the world or, dump on someone or something. But if this is not something that is your mission and your values and where you're heading, this will fail. So, and I'm sure I'm speaking for all of us. So, and I mean, in particular, yes, so sure, we are going to open source, decentralized, all parts, the sequencer in particular. I should say that, we're waiting. Okay, so first of all, the amazing LambdaClass team, which is building every time Fed is not moderating something, and he and his team are coming back and reporting 10x or 100x improvements on various aspects of things that will be part of the sequencer. And this will come out and be out there. And as you can see on the various forums, we're working very hard to research what is the best out of many, many existing solutions for decentralizing and having a protocol out there for everyone to use for Starknet. But I'm sure everyone else is doing the same. So if you don't decentralize, it will fail, period.
Yeah, I would like to add to this that there's a complexity that you add in decentralization. I mean, anyone who has tried to decentralize the sequencer knows that trade-offs are quite complicated. Same thing for the prover. But, and as well, yes, you're giving away power by doing this. And the complexity comes from people are going to run your software from any part of the world in a good way, in a bad way. They should be sending messages. They won't send messages, this type of stuff. But as well, what we're going to get from this is improvements to the system. People will find ways to improve a prover. They will find ways to improve a sequencer. They will challenge it as well. The fact that it's open means that if you do something bad, they will see it. If you can do something better, they will tell you. So that's going to make the system much better. So there's a complexity that you're paying at the beginning, but there's a huge benefits that you're getting globally at the end. Maybe not us directly, but everybody, us included. And I think it's important to see this.
Yeah, and just before Kelvin jumps in, there's a great example of Flashbots where the validator stole what was $2 million or something. So you got to make sure yourself, the protocol is really secure.
I just wanted to piggyback off of Ellie's thing that this decentralization or this, this dispersion of control is, there's two things. First, it's not dogmatic, right? It's not decentralization for the sake of decentralization. It's, there's a sense of we want to give control to people, right? And we sort of want to reduce the existence of these actors within the system that hold outsized control. So, but first of all, yes, I agree. I think you're completely correct that if you're thinking about this, there should be this natural urge to decentralize because we understand that the value of these systems is in the decentralization in this, or at least in the dispersion of control, right? And giving control back to users in a sense. I think it's important not to forget that this same principle applies not just to technological decentralization, but also governmental decentralization within these systems, right? Like plutocratic governance is not a functional we can't just say whoever's the richest has the most control within a system. That's not a system that gets worldwide acceptance. No one's gonna, none of my friends are gonna say that works. And so I think we just have to remember that these same principles of decentralization have to apply not just to the technical, these things are fundamentally social objects. And so these same principles of dispersion of control need to apply to the meta systems that govern these technical objects, right? And so it's something that we should think about on every single level. I think it's unfortunate that we often get very stuck within the technical side of this and forget that these are very social objects.
Completely.
I prefer governance-less systems, at least as much as you can.
Yeah.
But that's it's easy to say, but what is?
I agree. But but when you are designing, if you have that in mind, if you can avoid a parameter that needs to be managed by governance,
you're right.
Avoid it. Right. That's for me. That's the point.
I agree. I would just implore everyone in the space to consider, novel mechanisms of governance, because the reality is that there's no way we get to a worldwide system if we just stick with the same, I don't know. I feel like the economic systems we've created to govern these, the technical stuff is fantastic, and then we've just completely dropped, this other half of the equation. And I think that's the next great frontier, because I think we're getting quite close. Like with all the zk rollup stuff, where I think within the next decade, we definitely get sort of towards the end of the road as far as technical decentralization, technical scaling, and then we have the next great challenge, right, which is governance in these ecosystems.
I want to commend the optimistic, like the OP house and the governance model there. It's like really trailblazing, and it is peace on L2. So I think
yeah,
there's a lot of
I
inspiration
appreciate that.
there. The two houses and the retroactive public funding and a
This
lot of
is
very
go ahead, Calvin, and then we need to move to the last topic, but it's very related to the things we're discussing. So if you can,
Sure.
Calvin, the idea.
Yeah, I was just saying, it's not perfect, right? It's none of this stuff is, but I feel like it's very, very important that we don't put our heads in the sand and get stuck on the technical stuff, because the reality is that these things are not technical objects for the sake of, they're very stimulating intellectually. Of course, it's fun to work on these things, but at the end of the day, we're building these for the sake of real people, and these systems need to function for real people, right?
So the last topic is related to these last few comments. We can so you can give a few comments about the technical challenges you're having, or the second option is also to discuss things that you like from another L2 that can be technical or non-technical, like the comment that Elicious did about Optimism on the governance. So who wants to go first? It's a more open section.
Can I go first?
Sure.
Yeah, sure. Who wants
Okay,
to
so
go?
first of all, I envy the Polygon teams for going with small fields. I think it's really, really wise. That's really great. I think as I said, the Optimism team, in terms of like having its heart in the right place and thinking about the community, is like absolutely amazing. I think Arbitrum is doing an amazing job in attempting as much as possible to deliver on secure fraud proofs. I mean, there's more to be done there in terms of opening the challenging to everyone as is needed, but they're really, I think, very, very impressive there. But all in all, I think it's very clear that we're all going in the same direction of allowing infrastructures for implementation of social functions for social goods in a way that is truly barrierless and ultimately in the hands of people, hopefully for the benefit of humanity.
I'll return the favor to, like, there is one thing I like about, well, there are many things that I like, but one thing that I like specifically about StarkWare is simplicity of Cairo VM. I think if you can write constraints on 2 pages, that's like so elegant and so simple that this is like one really, really, really cool thing about design of Cairo.
Alex?
I can go next. I want to say that every single one on this call has made a big contribution into the space, and like I can think of distinct innovation that each project brings. And starting with Eli, who is, I think Eli is the father of Starks and Starks in general. Like we all of us owe to him for this space to be in existence overall. Jordi is doing amazing work with Plonky 2 implementation and bringing like the first EVM equivalent zk EVM is there, and this is huge progress. Nicola and Linear team is building is bringing lattices for the first time that I know in actual production systems. Scroll is working on actual like EVM implementation in circuits. Bobbing is doing great work with Starks and like deviating from EVM and experimenting with pure StarkWare systems. Arbitrum is doing this EVM plus, bringing different languages to. You guys are probably going to be the first ones to bring new languages to Ethereum space, like compiling Rust. Optimism is doing an amazing job on the ecosystem innovation and governance innovations. LambdaClass is bringing the full node for Starknet, which is and like you guys are doing a lot of interesting things. But I want to focus on one specific thing that I really, really like about optimistic rollups that we actually stolen and borrowed for zkSync. That is this idea that in the early days of all the systems, we're gonna have, like, we cannot account for all errors, and so this human intervention and governance will be important to act as a safety net. And like optimistic rollups kind of have this, I don't know, I think it was unintended consequence, but having the fraud proof period significantly long so that humans can see the problem and intervene and not just react with the fraud proof, but actually like intervene on the governance level and make fixes in the system before it's too late, before the funds are completely withdrawn, is a huge thing. It's like, yes, it introduces this delay, but if you do it initially for this bootstrapping period, it's a massive win for security. And so we actually implemented this for zkSync Era. When we launched, we only have 24-hour delay on withdrawals because it's a secondary protection. It's like 2FA. The main security mechanism is still snarks. But if we have any problem with snarks and we spot a malicious transaction trying to withdraw a lot of funds, we can always look into it and do an upgrade to mitigate that. So huge kudos to all optimistic teams for bringing this into existence.
Calvin.
Cool. Yeah, see, now I feel like I have to go through every project and one for Jordy, one for I guess I'll just do it all at once and basically say, there's sort of a position of, I don't even know what you would call it, but maybe even cowardice in sticking with the EVM, hardcore EVM equivalence maxi. But the reality is that, like, we need people to try things outside of the EVM, right? Like, nothing evolves, nothing changes, nothing improves if people don't do this thing where you break out of these local minimas by reaching out. And I feel like really, every other project here is pushing that pretty hard, and it's nice to feel like, I have faith that people here are going to find the new local minima for us to all fall into, and that's that's a brave, it's a risky thing to have to do, and the reality is it's quite brave, and when it works really well. So I appreciate the people who take those risks.
So I'll guess I'll go through the list. So let's start with StarkWare. So first of all, kudos for sticking to their guns. So they kept using Starks when people thought that it didn't make sense. They didn't go with the trodden path of implementing EVM. Instead, they built something completely different. And obviously, Eli is the father of Snarks and Starks, so we all owe a lot to them and to Eli specifically. Polygon, zkEVM, there are a lot of things. So Jordy has been building zk rollups forever. So Polygon Hermes has been launched a long time ago, and it was one of the first zk rollups around. And of course, Plonky 2, which is an amazing proof system, which is super fast, is gonna help us all move forward if we don't want to just stick to like the systems that we had before. Then Linnea, Nicholas, while we us zkSync and Polygon were fighting about the definitions, you are quietly building in the background and not really getting involved with all those fights, and just came out with an amazing product. Bobbin, you guys didn't stick to building just what everybody else is building and chose a completely different path, and I'm excited to see what you come out with. Arbitrum, godfathers of fraud proofs, have been around for ages, are already running with fraud proofs on the mainnet, and it's super cool to see how things have progressed. Optimism, Plasma Group have been around the L2 game for ages as well, have pivoted multiple times, and kudos for them to basically always being on the forefront of innovation and not being afraid of changing things when changes make sense. And zkSync, Alex, and the entire team have been working on L2s, I think, since 2017 and have contributed a lot to the entire space. The first zkSync Lite has also been around for ages, and I think helped me personally understand a lot more about zk rollups and basically get better in the space.
Patrick, on
Yeah.
Nicolas, if we can do we only have a few more minutes, so if we can be a little bit
I'll
faster.
be pretty quick. I need to go to bed now. I think my girlfriend's going to kill me. You can see the light just went out. Yeah, okay. Well, basically, what's the best way to summarize this? I'll just go based on the order that I can see. So I think for Ellie, I think for Starknet in general, I think what I've always been impressed by is the firm opinionated design and not swaying around the pivot, opinionated design, being very firm on we're going to build Cairo and we're going to go for this. On Solidity, you can just disappear. And I really like that because it sort of follows how I see rollup should be built. They should be able to differ away from the EVM, but still be, Ethereum aligned, whatever that means, but still, inherit security from Ethereum. Maybe going to Jordy and Polygon. I still remember Hermes. I still remember some of the fundraising calls for Hermes. I was really impressed by the team at the time. And I think you made the right choice to join Polygon, and you really cultivated this culture internally for the different teams to work together. That's probably not as obvious for many outsiders, but I know there's like 4 teams there, and you all have weekly calls together telling about what you're all working on. And I think that's obviously helped both your product and Maiden as well. I guess for Nicolas and Lina, I remember like 2 years ago we had this call about your funky hash-based rollup scheme. I forget what it's called now. It's called like Rump or something. I can't really remember the name of it now. But as Togrul said, you've been very quiet. But I've seen inside ConsenSys internally that you were building up a team, and I was working on Vortex, etc. for a very long time. And just out of nowhere, it goes, oh, here's this rollup that we built and just deployed. So I guess most people didn't really see that coming, but I guess I got to see it because I was working at ConsenSys at the time. So it's really cool to see that whole life cycle going from this crazy hash-based scheme to an actual full-on ZK rollout. For Togrul and Scroll, I mean, obviously Togrul's a bit of a troll on the internet, so I like that as well. That's really fun. I get to enjoy that. But what I really like about Scroll is they're probably the most Ethereum. I know we all get the word Ethereum aligned team, but their goal is basically to build like a zk EVM that will someday be part of Ethereum. It's not even just about the roll-up. It's really about, can they build the right software that will eventually be adopted by the Ethereum network? And I think that's a really cool goal. I think that's really ambitious. So I just really like that goal about the team. And then for Maiden, I don't think I've ever heard anyone describe it this way, but you're basically Bitcoin on Ethereum. You basically have Taproot under the hood, the way you've designed your transactions and your scripts. I watched the talk about it recently. I'm like, that's his Taproot. So that's really cool. You basically built Bitcoin. So GG, that's a great job. The UTXO model. Then for zkSync, so I guess what I always respected was sort of, it's very super product focused. You kept a lot to your, close to your chest over the past year to make sure you could launch everything and surprise everyone when you did it. And I always found the zkSync code really easy to read. zkV1's basically says a few contracts, and it's really simple. Don't think there's any assembly there because I was able to read it, so it was very, very nice. And also really good cheap gas costs. I think a transfer was like 800 gas on V1, which was the cheapest out of the rollups back then. And then finally for Calvin, I guess what I remember from Calvin is I remember 5 years ago when you rolled out the IC3 your little backpack, the talk of a little water bottle, the chat about plasma. I still have that image in my head. I think it's hilarious. And I guess it's just really cool to see Optimism's, this vibe surf and just, worked on it for the past 5 years. You went from Moonbees ago, from plasma, the OVM to now what you're building now with Bedrock. It's really cool to see just that progress. So obviously just very impressed by that, and I like the way you think. So GG guys.
And I will go last and quick. So for Ellie, yes, I read the tiny one paper a while ago, and I executed the code, and it was taking a lot of time and all this progress that has been done where it was just theory and became practice. That was very useful. And from Jordi, for example, we learned how to decompose the modules. Like we are saying, oh, it's very complicated to do the arithmetization. And we had this presentation by Hermes around, oh, but you just need to do modules. So we did modules, and yes, it helps a lot. Scroll, I mean, there's all this community-driven. I think it's very important. It's something that I really appreciate in the Scroll's approach. Everything is open source. It can be messy, it can be not messy, but it's open source, it's shared very, very publicly. So that's very, very good. And I really appreciate this. Bobin, if I'm not mistaken, we own you the Goldilocks, not the curve itself, but the fact that we use it. You will correct me if I'm wrong, if I misinterpret this. I'm sorry about it if it's only wrong.
I would give the credit more to Daniel and Brandon from Polygon Zero team.
Okay. Patrick, I mean, yeah, we've been working together. I mean, this analysis that you've done in rollups. And actually, when I arrived to a blockchain in 2017, I went first to actually ETHCC. Just later, and it was a presentation by you about some attacks using the blockchain to do some attacks. That's very, very useful. So kind of, it was the first presentation that I had ever seen on blockchain was from you. Kelvin, I mean, yes, all this work on optimism. I mean, it's you started the way, as well as this logic about open source, the logic of modularity, what you were saying about zk rollups, as implicitly you can have sequencers when you can have proof or fraud proof. I think that's very useful. Alex, I read your paper, your blog post on zk rollups. I think it was in end of 2018. And when I read it, I saw, okay, that's how we can do scalability on Ethereum. So that's basically you're the one who introduced me to rollups. And Federico, we met, and I know that you're working a lot on Stark and so on, and you're helping this world to be successful. So thanks a lot all.
I would like to I don't know if I'm the last or not, but
yeah.
So I would like I'm the last. So I would like to just to mention that here we are all in the same we have the same goal, we have the same work. We are trying to scale this technology and bring it to the maximum people. Okay, and maybe sometimes for somebody that's just reading Twitter may think that we are like all in a fight and fighting a lot, and so of course we have our divergences and different ways to see different things, but people should know and must know that we are working together. At least in the technical people, we are working a lot together. We are stealing a lot of ideas, one each other, and that's great. I mean, from StarkWare, we are stealing all the Stark that comes from their side. From Nicola. I mean, we are waiting for this lattice stuff that's looking amazing, and we're waiting for that. And all the ideas in the limitization are in there. From Tukul, I mean, there is a lot when you're doing an EVM or compatible EVM. You have a lot of challenges, and they solve a lot of the challenges that we are using in our EVM. In the optimistic rollups, I mean, they are the first rollups for me. You know, they are the first at least the EVM rollups, and they have like 2 years in advantage in what means in understanding what means running our rollup on that. We're learning a lot from them. This idea of sequencers, all this was introduced by them, so it's a lot of value that they added in the front. Alex is doing an amazing job in bringing developers. If you see the documentation, zkSync is incredibly good. I mean, having to all this tooling and all this tooling is a little complex, and I think they did an amazing job in this front. And so it's and if you see, for example, or in the technical side, I mean, not this Alex, the other Alex. I mean, he was just explaining how to read the polynomial, how to extract data from the polynomial commitments in the IP 4844, and I mean, there has been a lot, and it is a lot of collaboration between us. It probably should be more. I mean, but that it should be a lot. So this is a common work. I mean, this is a common goal. And we will make it. I mean, that's for sure. I mean, we will make it sooner or later, and this is where we are.
So thank you everybody for joining in for StarkWare for organizing this, and for the rest of the teams for letting me the moderator. I think it has been an amazing example, not only for the industry. This is not very common in Web2 or in other industries. And I think it shows the potential of Ethereum on the L2s in a very complex world where even a trademark is a big discussion. So thank you, everybody.
Thank you.
Thank you.
Thank you, Federico. All right.